Okay, so hi guys, welcome back to my channel. So this is going to be the first video of my LLD problems playlist. So in this playlist, we are going to see each and every problems that can be solved using that LLD pattern. If you all don't know, I have the LLD patterns playlist that is going on. I have recorded the creational design pattern and behavioral design patterns. So I thought why not to start a problems in which we'll be implementing those patterns in order to solve the real world problem. So let's start with this UML class diagram as the first video of this playlist. Why? Because whenever we'll be solving the problem on that videos, I'll be using the jargons. There'll be a lot of jargons. So I want you all to understand those jargons, those relationships while I'll be explaining the UML class diagrams. So let's start this video. So what is UML class diagram? It is nothing but a unified modeling language. In order to showcase the structure of the problem, it is an ordered way to structure our solution, to show the relationship between different components. Okay, so it represents classes, attributes, methods, relationships within a system. So in order to represent the classes, attributes, methods, relationships and their mappings and their relationships between them, that is why we are using UML class diagrams. So this is all a component looks like. So if you'll see here, the components, first one is the car, which is nothing but the name of the class, we can say. These are the attributes, means the variables which will be defining inside the class, and these are the operations, means the methods that is there in the class. So before going forward, let's understand four types of visibility in UML class diagram, four visibility notations. So the first one is the public, which is denoted by plus, private, which is denoted by minus, protected, which is denoted by hash, and package default, which is denoted by this tilde, I guess. Now you all can see before every variables, you can see this is the notation minus, which means that it is private. These are plus, which means that this is public, and these are the types: string, string, int, method return type, void, void, int. Okay, so now let's move to the relationships that can be between the classes. So the first one is the composition, direct association, usage means dependency, generalization, aggregation, association and realization. So with these four relationships, you all will be very clear when I'll be explaining all the UML class diagrams on the problem statements. So just listen very carefully. So the first one is the generalization, which means that inheritance. Whenever we are inheriting, we are using this term generalization, means so how we depict this generalization. So there will be a solid line with hollow triangle. Can you see this? Solid line with this hollow triangle. So it is a relationship. Subclass inherits attributes and methods. Okay, so you can see here we have the class component and we have the class button. So button extends this component. So whenever we see class button extends component, so we'll say it like this: button extends component. So this is the notation that we are using for generalization. I hope this is clear. Means generalization means simple inheritance. Now let's move to realization. Realization means interface implementation. So it is denoted as dashed line. So class implements an interface. We have this interface, we have this class, it is implementing this interface. So we are showing authentication dialog implements interface. I hope this is clear. This is the simple. Okay, this is very simple. So first one is the inheritance, second one is the interface implementation, means realization. Third one is the association, means a solid line with no arrow. This is the solid line with no arrow. Now one class has a reference to another. Okay, so we have one class, it is referring to some other class. So we have component and we have solid line and mediator, means general connection. It can be bidirectional too, but solid line is used to refer the association, means class having the reference to another class. Now let's move to direct association. Direct association means a solid line with arrow. One class knows about another in a specific direction. Let me give you an example. So we have class customer, and inside that customer we have order. It means that customer knows order, but it is not vice versa, because in order we have only ID. Okay, so customer knows order, it is unidirectional. Customer knows order, but order doesn't know customer. So as I have told you, the solid line means a class has a reference to another. It can be unidirectional, it can be bidirectional. So directed association means we are directing something. Okay, so customer knows order, but order doesn't know customer. It is a unidirectional. Now let's move to dependency, which is nothing but the usage, the dashed line with open arrowhead. So temporary use of another class, parameter or local variable. Let's say we have this class, inside this we are using this component. Okay, we are using this component. So what we are doing, so authentication dialog, we are using the dashed notation with arrowhead and we are showing to component. So component is being used inside authentication dialog. I hope this is clear. I guess there will be a small change. So instead of this hollow triangle, it will be a arrowhead. As you can see here, it is a arrowhead. So hollow triangle, no, it will be a arrowhead. Now let's move. So directed association is also done, dependency is also done. Now let's move to two big chunks, which is aggregation and composition. Okay, now what is aggregation? So first let's see how we denote aggregation. So we denote aggregation as this solid line with the hollow diamond, the solid line with the hollow diamond. Aggregation means whole part relationship. Parts can exist independently. Okay, so let me explain you with this example. So we have class team, list of players can exist independently. We have this class player. Now let's understand what aggregation is all about. So team has a list of player objects. As you can see, this team has a list of player objects. The player object are not created inside team. We are not actually creating the player object inside the team. So what is happening? So lifecycle independence means if a team object is destroyed, the player object still exists in memory or in another team. What does it mean? So let's say, I'll show you with the code example. Okay, so let's say player P1 is equals to new player, player P2 is equals to new player. Now when I'm creating the team, I am referencing the team players to point it to P1 comma P2, means list of players. Let's say in future the team gets destroyed, this gets destroyed, this gets destroyed, but still this will remain exists. Okay, why? Because this is not created inside the team. So that is the same thing it is saying. So the player object are not created inside team. They can be created elsewhere and then added to the team. Means whenever we'll destroy teams, the player still can exist. So the team only holds references to player objects. Team only holds references to player objects, but not the actual objects. It doesn't own their life cycle. Arrow meaning hollow diamond. Hollow diamond means loose, whole part relationship, means loose relationship. So it means that aggregation means you cannot control their life cycle. Okay, now let's move to composition, which is just the opposite of it. So solid line with filled diamond, solid line with filled diamond. What it says, house creates and owns the room object inside itself. We'll see here, this house will create and owns the room inside itself. Why? Because we are creating the object here. Now the room object is tightly bound to the house. It cannot exist independently because it's instantiated inside the house. This cannot exist independently because a room is there inside the house. Lifecycle management, if the house object is destroyed, the room object is also destroyed. Memory management, the house controls the life cycle of room. How we can remember? Filled diamond means strong whole part relationship. Let's see the code. So here we have house. Here we are doing room r is equals to house dot room. Room r we have declared, and here we are initializing. House dot room means whenever we do house, whenever we do house is equals to new house, we have already created the room. Why? Because in this class we are creating the room. Just what we are doing, we are doing room r is equals to house dot room, means that object which is created in the house we are referencing to room r. When the house becomes null, that object will also be destroyed. When house is destroyed, room is gone too, means room will also not be there, means this will also not be there. Okay, I hope this is clear. I hope the 7 types of relationships that are being used in UML class diagram is clear. I hope the visibility is clear. So see you guys in the next video, which will be most probably a parking lot problem. So thank you for watching and having patience. So thank you.